Hello everyone, Namaskar, welcome to Maths Guidance and welcome to the third lecture of chapter 5, that is Introduction to Euclid's Geometry. And so far we have discussed the history of geometry and Euclid's postulates, axioms given by Euclid's. So that portion is completed, and now today we are going to see some geometrical terms like what is a ray, what is a point, what is a line segment, what do you mean by a statement, what do you understand by a theorem, corollary, collinear points, intersecting lines and concurrent lines. So we are going to see the definition and examples of these terms, and after that we are going to solve some problems based on these topics which we have studied. And later on in the fourth lecture we may conclude the chapter in the fourth lecture by the question and answer session. So friends, let's start the lecture 3 by this topic, some geometrical terms. Okay, and the first one is a statement. So what do you mean by a statement? A statement is nothing but a sentence which can be judged either true or false. That means, let us first write it. A statement is nothing but a sentence. A statement is nothing but a sentence which can be judged either true or false. Nothing but a sentence, which can be judged either true or false. Which can be judged either true or false. Either true or false is called a statement. Either true or false. Okay. A statement is nothing but a sentence which can be judged either true or false. That means somebody makes a statement, makes a sentence, he speaks something, and you have to check, you have to judge whether it is true or false. Like if I say that the area of a circle is 4 pi r square, let us say the area of a circle is 4 pi r square. This is a sentence. Okay, this is a statement. Now you have to check it is true or false. It is not true, it is false. All right. So this was the example. So this is a statement. So you can judge it whether it is true or false. All right. Now let's come to the second one. Second one is, we will see what is a theorem. What is a theorem? So a theorem is a statement that requires a proof. A theorem is a statement. It is a statement which requires proof. Okay, it is a statement which requires proof. The definition of theorem is this. Now when it requires proof, then you will establish the proof, and that process will called the proving of theorem. Establishing the truth, establishing the proof or the truth is called proving the theorem. Because it requires a process. Because of that process you prove it that this is a true statement, this is a theorem. So this is called the proving the theorem, whether it is true or false. All right. Now the third one is corollary. Now what is a corollary? A corollary is a statement whose truth can easily be deduced from a theorem. Okay, it is a statement whose truth can easily be deduced from the theorem. All right. It is a statement whose truth can easily be deduced from the theorem. Means if you have the theorem, then it can be easily deduced from it. So it is called a corollary. Now I hope you understand all these three things. Statement. What is a statement? Is nothing but a sentence which can be judged either true or false. Okay. Like the area of a circle is 4 pi r square, and we can judge that it is not true, it is false. So it is a statement. Okay. Now theorem. It is a statement which requires proof. And in the process of establishing the truth is called the proving of theorem. Now what is a corollary? It is a statement whose truth can easily be deduced from the theorem. So with the help of theorem we can easily say that this is true. So that is a corollary. Okay. Now let's move on. Let's come to the fourth one. Fourth one is the point. So what is a point? A point is an exact location. It is an exact location, and we call it a fine dot. It is an exact location and we call it a fine dot. And we show it like this is a point, and we denote it by a capital letter. Denotion is by a capital letter. Denotion by the capital letter, like A, B, C, D, whatever we can denote it with a capital letter. So here we are showing it by P. So this is a point. Now let's come to the fifth one. Fifth one is a line segment. Line segment. So a line segment is the straight path between 2 points. Suppose here we have taken point A and point B. This is the straight path. So the straight path between 2 points is called a line segment. The straight path between 2 points is called a line segment. Okay. And how we denote it? We denote it by this A, B, and like this bar. This is the denotation of a line segment. And the points A and B are called the end points. A and B are end points of a line segment. End points. Alright. The straight path between 2 points is called a line segment, and A and B are the end points of that line segment. Okay. And we denote it by AB, and on the top of it a bar. Now you can see that a line segment has a definite length. This is the length of the line segment. Alright. So the distance between 2 points is equal to the length of the line segment. The distance between 2 points is equal to the length of this line segment. Now come to the sixth one, that is a ray. What is a ray? So a ray is a line segment when extended on one side. Suppose this is a line segment A and B, and we extend it this side. So this will become a ray. So it is a line segment. It is a line segment when extended in one direction, or one side. So when a line segment is extended in one direction, it is called a ray, and we denote it like this, AB, and like this arrow mark. So this is called the ray. Alright. And a ray has no definite length. It has no definite length, because you can see through this picture, it has no definite length. You extend it in one direction, it has no definite length. At whichever distance you can extend it. So this is the concept of ray. It can only be drawn. Okay. It can only be represented on the plane of a paper. It cannot be drawn. It can only be represented. Okay. Number 7, let's see what is a line. What is a line? So a line is actually when a line segment like this is a line segment AB, and you extend it in both the directions. So a line segment when extended indefinitely in both the directions is called a line. So basically a line segment when extended indefinitely in both the directions then it is called a line. It is called a line. So this is a line, and we represent a line with the symbol small letters L, M and etc. Okay, and how we represent it? By this A, B. It's a line. Okay, so a line has no endpoints. A line has no definite length. A line cannot be drawn, but it can be represented on the plane of a paper like this ray. It cannot be drawn, it can be represented on the paper because it has no definite points. One definite point, but second one is indefinite. Like here, there is no definite, both are indefinitely extended. So a line has no endpoints and it has no definite length. No endpoints and no definite length. And it cannot be drawn on the paper, it can only be represented. On paper. Because of the reason you can see it is indefinite in both the directions. Okay, so let's see what we have understood. Statement, theorem, corollary, point, line segment, ray and line. All of these definitions we have seen. Now let us understand some more definitions and then we will go on the question and answer part. Okay, so let's move on. Now let us understand some more definitions, some more things, some more terms, and out of those one is incidence axioms on lines. Means we are going to see the lines, incidence axioms on lines, so based on the lines and points. So first one is a line contains infinitely many points. A line contains infinitely many points. All of you may be knowing this. Line contains infinitely many points. You know all of this. Suppose this is a line. It has so many points, infinitely many points. So this is what is written in this incidence axiom. Now second one is through a given point infinitely many lines can be drawn. Through a given point infinitely many lines can be drawn. Infinitely many lines can be drawn. You know it very well. Suppose this is a point. Through this you can draw so many lines. You can draw through it. Okay. So this is what given in the second axiom of incidence axioms on lines, that through a given point infinitely many lines can be drawn. Now let us check the third one. The third one also you know. It is that there is only one line which can be drawn through 2 points. That means one and only one line can be drawn to pass through 2 given points. One and only one line can be drawn to pass through 2 given points. You know it very well. That is called the unique line. Suppose this is 2 points A and B. You can draw one and only one line like this. Okay. So this is what the third axiom on this incidence axioms on lines, and they are called the incidence axioms on lines because they are based on incidence like this. All are incidencing. So first one is a line contains infinitely many points. All right. Through a given point infinitely many lines can be drawn. This also you know. And the third one is one and only one line can be drawn to pass through 2 given points. That is a unique line. Okay. Now let's understand what is a collinear points. Collinear points. What are the collinear points? So as the name is suggesting, it is like this. Suppose this is a line P, Q and R. So all these 3 points are lying in the same line. That means they are collinear. So 3 or more than 3 points are said to be collinear if there is a line which contains them all. 3 or more than 3, because 2 cannot be possible. So 3 or more than 3, 3 or more than 3 points, 3 or more than 3 points are collinear if a line contains them all. This line is containing them all. Suppose you draw like this, PQR or ABC. This cannot be a collinear points because there is not a single line which is containing them all. You cannot draw like this. This is not a line, okay? Or it will be 2 lines like this. So these are not collinears. So the definition is like this, that 3 or more than 3 points all contained by the same line like this. So they are collinear points. Now let us come to the intersecting lines. Intersecting lines. You may be knowing all these things, but let's revise. Intersecting lines are 2 lines having a common point like this. There is a common point. Let us take C. So 2 lines having a common point. 2 lines having a common point are called intersecting lines. Intersecting lines. All right. And this point will be called the point of intersection. This is called the point of intersection. Okay. Now let's come to the concurrent lines. So what are the concurrent lines? So concurrent lines are like this. If 3 or more lines intersecting at the same point, like this is a line, this is a line, this is a line, 3 lines intersecting at the same point. If 2 lines are intersecting at the same point, then it is called the intersecting lines. If 3 or more than 3 lines are passing through a common point, then these are called the concurrent lines. So 3 or more lines intersecting at the same point. 3 or more lines intersecting at the same point. Are called concurrent lines. Concurrent lines means they are all meeting at one point, and this will be the point. All right. So if this is line M, L, this is line M, this is line N, this is line O, so all these lines are meeting at the same point. Okay. So these lines are concurrent lines. So intersecting lines, there will be 2 lines. Concurrent lines, there will be more than 2 lines, more than 3 lines. Okay, 3 or more than 3 lines. Collinear points, I hope you have understood these things, that 3 or more than 3 points are collinear if the line contains them all. Okay, and then this instance axioms of on lines. First one is a line contains infinitely many points. It's an obvious thing, you all know it very well. A line, this is so many points, infinitely many points. Through a given point, infinitely many lines can be drawn. This is also okay. Third one is one and only one line, and that is called the unique line. It can be drawn to pass through 2 given points. So I hope all these definitions are clear. Let's move on. Now let's do some problems. I have taken these questions 1, 2, 3, 4, and here true or false 1, 2, 3, 4, 5, 6, 7. Okay, let's do it. It will clear the theory portion which we have understood, which we have read. So first one is, how many lines can be drawn to pass through a given point? Suppose a point is given. So how many lines can be drawn? We have read that infinite lines, infinitely many lines. So the answer is infinitely many lines can be drawn through a given point. Infinitely many lines. The second one is, how many lines can be drawn to pass through two given points? Through two given points we can draw only one line. Alright, only one line we can draw. So the answer will be only one to pass through two given points. Now the third one is, in how many points can the two lines at the most intersect? In how many points? Suppose these are the two lines. They can intersect maximum at one point. Only one point. One point maximum. One point only. Okay. Fourth one is, if ABC are three collinear points, name all the line segments determined by them. So let's do it like line segment we have been given, line segments. Okay. So let us suppose A, B, C are collinear. A, B and C are three collinear points. Alright, name all the line segments determined by them. So we have to write the names of the line segments. So first one will be AB line segment, second one will be BC, and third one will be AC. So this will be our answer. First line segment AB, second line segment BC, and third one is AC. I hope this is clear. Alright, AB, BC and AC. These are the line segments. Now come to the true or false portion. First one is, a line segment has no definite length. A line segment has no definite length. This is false. Why? Because if you see, what is a line segment? It is like this. This is a line segment. Okay, so it has a definite length, and here it is said that a line segment has no definite length. So this is a false information, false statement. A line segment has a definite length. All right. Now second one is, a ray has no end point. See, second one, this is called a ray. It has one end point. One side it is extended. So a ray has no end point. It is also a false statement. False statement. Okay. A line has a definite length. Now see, what is a line? This is a line AB. This is a line. It has no definite length. It has a definite length. It is also false. It is also false. Okay, I hope you can recall all these things. That is why I have taken these problems. Now the fourth one is, a line AB is the same as line BA. Okay, let us see. Let us see AB. So a line AB is same as BA. It is same, no doubt. It is same. Is the same as BA. So it is true statement. True. Now a ray AB is the same as ray BA. This is not false, because this is A, this is B. So we are extending this side. So this is AB. Now if we extend this side, this is BA. Okay. So a ray AB is the same as ray BA. It is not true. A ray AB is not same as ray BA. It is moving this direction. It is moving in this direction. So this is also false. This is also false. Fifth one is also false. Now sixth one, two distinct points always determine a unique line. Let's see. Two distinct points always determine a unique line. This is true statement. So this one is true. True statement. Sixth one is true. Seventh, two distinct lines cannot have more than one point in common. Two distinct lines. Let us suppose two distinct lines. Okay. Two distinct lines cannot have more than one point in common. It will have only one point in common, and it is given here cannot have more than. So this is also true. This is true. It cannot have more than one point in common. It has only one point in common. Two distinct lines can have only one point in common at most. So cannot have more than one point in common. This is true. If the lines are three, then they can have more than one point in common. But if the lines are two distinct lines, it cannot have more than 1.1 comma. This is true statement. So I hope this will recall your chapter. Okay, the terms, geometrical terms, statements and all these things, definitions. So let's now move forward. So guys, we have done all the theories related with this chapter, and so let us conclude this chapter here. Today the rest portion, which was the some geometrical terms and definitions, some axioms based on lines. So we have seen all these things. So I hope this chapter is clear to you. It was a logical part, logical chapter, so there was hardly any mathematical calculation. And let's finish this chapter in lecture 4, that is questions and answers session. We will do it very soon. So please be connected with my videos, with my channel, and please like, share and subscribe my channel. Thank you very much.